If you've ever looked up at a massive, towering steel skyscraper and thought, how do we know for an absolute fact that this entire thing isn't just going to buckle under its own weight? Well, the answer is actually sitting right here. Welcome to this explainer. Today, we're diving into the literal DNA of our modern skyline, the ANSI/AISC 360-22 specification for structural steel buildings. It's a 300-plus page engineering document that quietly keeps our world standing safe and tall. So let's jump right in and decode the rule book for structural steel.
To give you a quick roadmap, we'll be tackling this in 4 parts. The rule book for steel, a giant of steel design, what is new in 2022, and finally, a tour inside the Steel Bible itself.
Starting things off with Section 1, the rule book for steel. Now, everything in this explainer is pulled straight from the ANSI/AISC 360-22 specification. It's published by the American Institute of Steel Construction, or AISC. These guys have been the absolute authority on structural steel in the U.S. since 1921. And this specific August 2022 release, it's the ultimate standard for designing, fabricating, and erecting steel frames today.
But here's the really important part. This isn't just one rogue genius in a room making up rules. Not at all. This specification was hammered out by a balanced committee using incredibly strict ANSI consensus procedures. Every single math equation, every safety margin, it's heavily debated and rigorously tested by a massive brain trust of structural engineers, researchers, and fabricators. They do this to ensure absolute, uniform safety across the board.
Moving on to Section 2, a giant of steel design.
It's pretty easy to look at a codebook like this and just see a wall of cold, hard math. But the 2022 edition actually opens with a really touching dedication to Dr. Theodore, or Ted, Galambos. The dedication specifically notes that his research literally transformed the AISC specification. Dr. Galambos was this beloved teacher and pioneer whose work completely revolutionized how we calculate building safety.
So what exactly did he do? Well, he spearheaded the shift to LRFD, which stands for Load and Resistance Factor Design. Before this came along in 1986, engineers were mostly relying on older, kind of rigid static safety margins. But Dr. Galambos realized we could use advanced probability instead. LRFD basically weighs the statistical likelihood of extreme loads, like, say, a freak snowstorm or a massive crowd of people, against the actual reliable resistance of the steel. It's just a much smarter, incredibly precise way to build.
And when you look at his career timeline, it's just wild. From getting his doctorate at Lehigh in '59, to being elected to the National Academy of Engineering in '79, and then officially introducing the LRFD spec in '86. This was a guy who spent decades laying down the invisible theoretical foundations that silently protect us every single day.
All right, let's hit Section 3. What is new in 2022?
Structural engineering is never stagnant, right? We're always getting better materials and better testing data. So this August 2022 standard officially supersedes the older 2016 version. And it brings a ton of highly specific state-of-the-art technical modifications with it. Let's look at some of the real game changers here.
Check this out. 144 KSI. That stands for 144 kips per square inch. To put that into perspective, a single kip is 1,000 pounds of force. So one of the biggest updates in Section J3 is the adoption of ASTM F3148 bolts. These relatively small fasteners have a massive tensile strength of 144,000 pounds per square inch before failing. That is a staggering amount of durability, and it lets engineers design much tighter, more efficient connections.
There are also some really critical updates scattered throughout the rest of the book. Section 8.4 now explicitly spells out exactly what needs to be on structural design documents. Section B8 clarifies dimensional tolerances so there's no guesswork. Over in Chapter I, they added new stiffness rules for concrete-filled shear walls. And crucially, Appendix 4 now includes totally new prescriptive steel fire protection design equations that are based on really intense ASTM E119 fire testing.
Finally, we've arrived at Section 4, inside the Steel Bible.
Let's take a high-speed tour of the table of contents, because the way they group the physics here is actually pretty brilliant. It starts with the absolute basics. Chapter A is general provisions. Chapter B sets your design requirements and loads. Chapter C is absolutely crucial. Design for stability, making sure the whole frame doesn't just tip over. Then we get into how steel handles applied force, starting with Chapter D, which dictates exactly how much pulling or tension a member can take before it snaps.
Then, things heat up. Chapter E covers compression, that crushing axial force pushing straight down on columns. Chapter F handles flexure, or bending, which is vital for your floor beams. Chapter G is shear, the force that literally tries to slice materials apart. In Chapter H, that's where the math gets really intense. It covers combined forces and torsion. Because in the real world, a beam isn't just bending. It might be compressing, bending, and twisting all at the exact same time. Chapter H is what keeps the steel surviving that multi-directional chaos.
But here's the kicker. You can have the thickest beams in the world, but if they aren't attached right, the whole thing comes down. That makes Chapter J the literal linchpin of the book. It's the ultimate instruction manual for connections. It tells you exactly how to do groove and fillet welds safely, how to space those high-strength bolts we talked about earlier, and how to safely splice massive chunks of steel or anchor columns straight into concrete.
And we aren't just talking about a perfect, sunny, windless day here. The code accounts for terrifying extremes. The scope calls out advanced scenarios like Section A1.1 for seismic earthquake applications, or A1.2 for literally building nuclear facilities. It even factors in human comfort over in Chapter L. It calculates for floor vibration. It minimizes wind-induced motion so you aren't getting seasick on the 80th floor during a storm, and it even accounts for thermal expansion because steel literally grows and shrinks as the temperature changes.
Rounding out the whole shebang, we have the appendices. These handle the really highly specialized evaluations. Appendix 1 covers design by advanced analysis. Appendix 3 deals with fatigue, ensuring a steel bridge doesn't fail after decades of constant traffic. Appendix 4 is all about surviving post-flashover compartment fires, buying precious time for people to escape. And Appendix 5 tells you exactly how to evaluate the structural integrity of older existing buildings.
It's honestly mind-blowing when you step back and realize the sheer volume of science, dedication, and rigorous testing woven into the fabric of our cities. This one document represents thousands of lifetimes of engineering knowledge. So the next time you walk into a towering steel building, take a second. Look up. Will you think about the invisible probability math, the ANSI consensus standards, and the unsung heroes like Dr. Ted Galambos keeping you safe? It really makes you wonder just how far structural innovation is going to take us next. Thanks so much for joining me on this explainer, and I'll catch you next time.